Hi everyone, welcome to IoT Show Deep Dive. My name is Pamela Cortez. I'm from the Azure IoT team and I will be your host for today. Deep dives are all about showcasing an end-to-end solution, deep diving in some sort of scenario. So I'm really excited that this first deep dive, we're going to be focusing on end-to-end industrial solutions with PTC and Azure IoT. So I have special guest here, Chafia Aouissi from the Microsoft Azure IoT team. I also have Joe Biron. He is the CTO of IoT at PTC. I made sure to say that correctly.
Did a good job.
And so we're going to go ahead, we're going to deep dive into an end-to-end solution. If you guys have any questions, I will be in the chat and answering your questions, and also asking Joe and Chafia those questions as well. So feel free to ask those questions throughout the deep dive. All right, let's go ahead and get started.
All right, thanks Pamela. So hi everyone, I'm Joe Biron from PTC. A little bit about PTC and a bit about industrial IoT, which is what we're really focused on here. So PTC is a company that focuses on software solutions for product manufacturers and industrial innovation. So what we mean by that is we're helping people who create and use physical products and machinery in industry. We're helping them to optimize the creation of those products and the life cycle management of those products. And so lately, we've been really excited about Internet of Things and augmented reality technology as it applies to those use cases. So we thought we'd take some time here today to get you a sense of what industrial IoT is all about and how we work with Microsoft in building solutions that satisfy these challenges in industry.
Thanks, Joe, and welcome indeed. In the past few months, actually a year, we have been working together with PTC to bring these industrial IoT solutions to our joint customers. And today we will deep dive into how PTC with a set of solutions are building IoT solutions for our customers on top of Azure IoT. And of course, feel free to ask your questions. We'll be happy to answer them. Let's get it started, Joe.
All right, sounds great. So first, just a fun little thing. I call this Byrons Law. So the quick anecdote, one day I was working on a project in IoT, and I found myself with a hard hat, climbing a ladder in a new building construction, and we were inspecting the PLCs and HVAC equipment. And it dawned on me that I went to school for computer science, and I've been a software developer most of my career. How is it that I ended up with a hard hat crawling around? But I was loving it. So how do you reconcile this cool new technology and pretty critical infrastructure? So it dawned on me, it's an interesting intersection when you think about if you plotted coolness of a new technology over time. So when new technology is born, it's the latest technology, it's the latest startups. Over time, it gets a little bit less cool, but if it hangs around, that by definition means it becomes absolutely critical to the way we run the planet. Think about alternating current in 1847. You might want to do a fact check. I think it was the Chicago World's Fair where Westinghouse and Tesla lit up 100,000 incandescent light bulbs with alternating current technology. At that time, it was really, really cool. Everyone was like unbelievable magic that they're seeing. Now we just take it for granted. There's alternating current everywhere. So over time, the cool technology becomes mission critical.
Yeah.
And what we're doing with industrial IoT, and in fact, any of our industrial solutions, we're taking the latest technology and applying it to the mission critical infrastructure that runs the planet. And I just think that's unbelievable.
Yeah.
Right? Isn't that fantastic?
It is. It's like we keep in the cool aspect while we work on the critical side.
Yeah,
so
exactly.
It's the perfect intersection.
Yeah.
Yeah. So that's industrial IoT for me, and that's why I spend my career doing this stuff now. Okay, so some use cases that we see as very common with our customers. Three main categories, what we'll call smart connected products, smart connected operations, and smart connected workers. So smart connected product means I've got an asset and I want to monitor it remotely. I want to optimize my use of that asset. Now, I might want to detect when it's going to fail, understand its current condition. That's very interesting and very quick value creation. But I may also use that connectivity and make the product more than it used to be. I might be able now to offer the product as a service. If I can remotely monitor the product, understand how my customers are using it, now I can offer that as an on-demand service as opposed to just a piece of gear that I sell my customers. So there's a whole category of use cases for industrial IoT where the product manufacturers themselves want to make their products smart and connected.
It is interesting that like these use cases are touching critical pillar in the business. Like if you look at the use cases that you are sharing, is like we have the product, like the connected product, but also the connected operation and the connected worker. And when we think of any business, we are like that business will be there to serve customers. How do they serve their customers? Like through product, and that product could be a physical product or a service. And like who is working and innovating that product is the workers, right?
That's right.
And then how do they do it? They do it through a set of process and operations. So it's really interesting that the industrial IoT applies to these different pillar of business and like is enabling to completely change the way the worker is doing their job, the way the product is performing, and of course for the business, how the operations are more efficient, we avoiding the downtime and so on.
Yeah, I mean, they really fit together. So smart connected products. In my operations, I may have dumb, unconnected products. With our IoT technology, we can help them get those operations connected to make them more efficient. And then, of course, there are the people. We're not looking to displace people. We're looking to help people do their jobs better, safer, and more efficiently. So that's industrial IoT, really kind of in a nutshell. Now, when we, Microsoft and PTC, look at the tech stack that you really need to deliver on these kinds of solutions, we see these main capabilities. And hopefully you can see my mouse here. So starting left to right, obviously, you've got devices that are going to be connected or connectable. There will be some software-based edge agent that is responsible for collecting that data through sensors or a control network and brokering that data transmission and applying data transformation logic, perhaps some analytics on site at the edge, but ultimately communicating those insights or raw data to the cloud through a cloud gateway. That cloud gateway is enabling storage and further processing of the data through an application enablement platform. This is where you would build your apps and implement your business logic and expose these insights and experiences to end users. And they'll use tools like UIs and UXs and reporting packages. Some data will go in cold storage for archival purposes. Some data will go into warm storage. This is operational data that you may want to read 5 minutes from now or tomorrow, as opposed to something that you're just archiving for posterity. And then there will almost always be another business system that you want to integrate with. I might want to automate the creation of a work order in a work order management system like a Dynamics 365. I might want to feed an ongoing machine learning process where I'm constantly training AI models to make better predictions about how my data is telling me that I might have a problem with my machinery.
And
go ahead.
Yeah, actually that piece is very interesting because when we talk about IoT, we think it's a new and a hype, but like customers and enterprises have been doing industrial IoT for years. But what we have seen is that previously, without the new cool technologies, all the IoT solutions were siloed and they were not talking to each other. So if we think for the earlier examples, like they had solutions to manage their product, they had solutions to manage their workers, and they had solutions or systems to manage their operation, but like these solutions were not talking to each other.
Right.
Yeah.
And like with these, with the newest technologies and this new kind of reference architecture with IoT, and we are enabling those systems, whether they are old systems or new systems, to talk to each other, allowing the data to flow seamlessly and providing the customers the possibility to get newer insights. So that's
right.
Yeah.
that's really I think one of the key advantage that IoT is bringing today to the industry, right?
Yeah, we're
Yeah,
connecting
yeah.
the things, but we're also connecting the people and connecting the other systems.
Yeah.
Exactly, and to add on to that, I think for the longest time for IoT, most people were focused on that connectivity, and now there's a lot more support for machine learning, not only in the cloud side, but even on the edge side as well. So we're seeing a lot more people doing more than just connecting devices, actually doing device management and having true intelligence.
You bet.
Yeah, so Jude, can you tell us more on how PTC ThingWorx and the different services fits in that architecture?
You bet. So these gray boxes can get lit up with some nice color. So this previous slide describes the capabilities. We're not talking about any specific services from PTC or Microsoft. So the way we light up these capabilities is in the following way: IoT Edge from Microsoft as the IoT Edge agent, and plugins from PTC that would allow that edge framework to speak to a plethora of connected machinery through our industrial connectivity drivers, also known as our Kepware technology, to do software and content management so that I can send calibration updates or configuration files to my smart connected product so it can better configure itself, and remote access, RAC, remote access and tunneling, so that I can take control when I need to do an interactive diagnostics procedure. I have the ability to do that through a tunneled network connection. And then moving to the cloud, you want to maybe talk about time series insights?
Yeah, sure. Before that, this guy wanted to add on the remote access. I think that's a critical thing in the industrial IoT, especially from a security perspective.
Yeah.
Providing remote access from outside of the factory network is, from a security perspective, like, hey, I don't want to do that, right? So with the Azure IoT solution, like IoT Hub, we are providing, and ThingWorx as well, we are providing the capabilities to remotely access the devices, the machines, while we respect and follow the security best practices, such as the service-assisted communication and so on. So those machines are connected to the cloud gateway, the IoT Hub, and the IoT Hub is, of course, following security best practices. For example, the connectivity is only initiated by the device and so on. And it provides the capability to make the data that we are collecting from the devices available for downstream services to consume that data. And as Joe was explaining earlier, it could be direct storage for archival, so that's why we have the Azure Blob Storage, but also have warm data path storage or analytics, and that's where we have time series insight, which provide the capability to also explore the data that we get from the different devices at scale. And also the Azure IoT Hub is connected to ThingWorx, and ThingWorx provide the capability to create different applications, and that's what we will drill down a little bit further. And I think we have a demo on that as well.
We have a pretty cool demo coming up, right? So maybe just to touch on each one of these boxes briefly, just so that you get a sense of what the tech stack, how the tech stack is realized again. IoT Hub helps us maintain a secure connection to edge devices, which are deployed in a factory environment, in an industrial facility, etc. Blob storage would be for historical archival purposes. ThingWorx is a PTC product. We call it an application enablement platform. And the role that ThingWorx plays in this architecture is to be the one-stop shop for understanding my asset. So it's real-time operational status. We have a connection through IoT Hub, which connects to IoT Edge, which connects to the machines. But there is other reference information that I need to understand about my asset. I need to know its warranty entitlement. I need to potentially know the bill of materials. What are the part numbers? If I've detected a potential failure on a motor shaft, I'd like to know what the part number is of the motor shaft, and so I can look it up in my parts inventory database. So there are these other customer business systems of record that also inform what's going on in the solution. So ThingWorx aggregates the 360-degree view of everything I want to know about this asset so that I can expose it to an end-user-oriented application, in this case, Asset Advisor, which we'll show a demo of as well. And that implies user management, so we connect to Azure Active Directory, which plays an important role in the architecture, and machine learning, which helps us determine when something's going to happen if a person is not able to configure the rule. So if I know when a voltage level drops below 20 volts, that's a potential problem in a particular part of my architecture, of my physical architecture, that's a rule, and I should be able to configure that very easily. It's when the people don't know what those rules are, when it's too complex or there's too much historical data that needs to be looked at to make the determination. That's a great use for ThingWorx machine learning and Azure machine learning as well. So let's take a look at a more concrete example here. This is an example industrial asset. It's actually a conglomeration of parts that you'll typically find in industrial machinery. So there's a programmable logic controller over here. This is from Alan Bradley. A PLC, and sorry if you know what PLCs are, but if you don't, they're basically the technology level of an Atari 2600.
They are. It's always fun working with them.
Yes, yeah. They're pretty basic. They're not high performance computing, although they do have an evolution in the near future where they could become that. But they're really for, I'm going to connect some wires from buttons and electrical outlets, and based on certain signals that are coming in, I'm going to provide certain outputs, very basic rules. So PLCs are often used to get operational status of an asset. And they don't do much besides just say, here's what's going on with this asset. So this PLC is wired into an IoT gateway, in this case a Bosch XKD. It's providing some temperature and humidity sensor readings as well, but it's also brokering our physical connection through Wi-Fi to the cloud, and it's running an IoT Hub SDK. And it's sitting on top of an electric motor which has a drive shaft, and in this case, this motor is not doing any real work. It's not connected to any kind of gears. It's not reciprocating anything. It's just kind of spinning freely. But it's going to represent a use case where the product manufacturer of this motor rig, which might be connected into any kind of other equipment, needs to understand how they can best service and maintain this motor setup. Okay, so that's the setup.
So maybe before we jump in, we have different type of connectivity as well. Like this is only one example of devices that we are able to connect to the Azure IoT Hub that we do through the SDK or also through other protocol translation. And I like your introduction about the PLC. When we do industrial IoT, that's all what we hear. Like the PLC word is like you hear it several times, and there are different type of PLCs out in the market. And maybe if you could touch a little bit on how we do that protocol translation as well now or a little bit later, that would be good.
Yeah, we've got a little demo architecture slide coming up, and we could talk about how these pieces are connected together.
Nice.
But before.
Real quick, sorry. A question I get a lot is what devices are already certified with Azure IoT? So we do have a device catalog, so just throwing that out. But as Chafia mentioned, and Joe too, that we have the device SDKs, and Azure IoT works on all different platforms and all different types of devices. So you're not tied to just using one programming language on one specific device with the operating system that you have to buy into.
You bet. So let's talk through a little story here. So this is the setup. This is our assets, our industrial asset. It's a motor. It's got a PLC. Now, imagine that I am a service technician of the motor manufacturer, and my customers are all over the globe, and they're running versions of my motor, my product, in operational facilities like manufacturing plants, industrial wastewater treatment facilities, maybe in the HVAC system of a building like the one that we're in right now. It's very interesting if I can ascertain what of my customer deployed motors have a problem today. Do I need to send a service technician? Could I potentially make a correction over the air by sending a configuration update, etc.? So this is a screenshot of our Asset Advisor solution for doing exactly that. In this use case, it would be for remote monitoring and remote service. So I can see a short list of assets that are deployed. And if I drill down into one, I might have gotten a trouble ticket notification through an email. I've clicked through the email, and now I see, and as a subject matter expert for this particular motor, I can see very clearly that there's a current fluctuation that's not normal. There are some current spikes. And so here's a great example, by the way, of where machine learning could inform a non-expert. So I just told a story where I happen to know something about what the current signature should look like on this particular motor. But if I'm a new technician, and by the way, we do have an aging workforce problem where the subject matter experts for a lot of this stuff are retiring, and we have to train a new generation of service techs and maintenance personnel. So machine learning could have definitely helped in this example. Maybe as in our next IoT deep dive, we'll connect the dots there.
Yeah, I think that's a good idea. And like to your point about the workforce knowledge, that's something that I hear consistently from our customers, especially like working with these big machines. I have customers telling me that they have like only one worker that would know how that machine works,
the
and like
machine
they
whisperer.
know.
It's like tribal knowledge.
Hold on, let me put my tongue on it.
And here's
It's
the
got a
daily page. Take that.
And I heard that multiple times. I mean, like it's hilarious if we are from the outside, but they are living that every single day.
Right.
And that's where I think machine learning and the new technologies bring. How do we spread that knowledge across the workforce instead of having only one person, as you mentioned, the whisperer.
The machine whisperer.
Exactly. And you can also see those changes in a long period of time too, which is nice because you'll have parts where maybe it's been running for 2 years and it's at its end of its life cycle. So it's nice to be able to view those anomalies and be able to do some predictive maintenance too.
That's right. Normal sounding when it's brand new and normal sounding when it's 10 years old might be different. And these are kind of all the nuances that AI can help us decode. Okay, so in our story, back to our story, I'm the remote service tech. I'm sitting in a call center somewhere and I'm looking at Acme Co's motors. There's a problem here. I need to dispatch a service technician. Maybe I've done it manually by clicking a button or it's been done automatically. Now, I'm a different person. I am the field service technician. I've got the hard hat on now. And wouldn't it be really interesting if I could combine the IoT instrumentation from this motor unit, the temperature, the sensor, the current, the voltage, and combine that with some repair step-by-step procedures. And so a fantastic combination that we found is to use a HoloLens device or really any other augmented reality device. HoloLens is really nice because it's hands-free. So here's a short video. Imagine you've got a HoloLens on and you're the service technician. So I'll scan this special marker here. It's a kind of a magical little mark. I'll pause there just to describe. Let's try that again. And this time I'm not going to advance slides. So this special mark, we call it a view mark. And what this is going to do for us is, I'll just pause right here, it's going to tell the augmented reality technology, which is computer vision technology, essentially, where Euclidean origin is on my AR experience. So we know now, okay, that is motor serial number XYZ. We know how to get its IoT Hub and ThingWorx based data history and real-time data. And I know when I want to place augmentations on the field of view, the digital artifacts that combine with the real world view, that is augmented reality, I know where to place them so they're perfectly placed where the person who developed this augmented reality experience, who would have used a tool like Vuforia Studio from PTC, where exactly they wanted that to show up. So that's what the mark is doing for us.
And again, think of the worker, maybe in some cases they never seen that machine, or they see it rarely or only on
I'm
simulation.
new on the job, my first day.
Exactly.
I don't know what this thing is. I guess it's a motor. They gave me a wrench and they told me I have to replace the motor shaft.
Yeah.
So I mean, how many times have you watched a YouTube video of doing some repair on your car? So imagine you could have an augmented reality display that shows you what the problem was. Let's go back up here a little bit. So on the right of my screen, I've got my instructions. I've got a fluctuating motor current. That's what the people back in the call center told me. I need to locate the right part. And by the way, augmented reality is highlighting for me where the motor is, in case you didn't know, Joe, that's the motor. And then my next steps would be, okay, what is the procedure for taking the motor apart? I need to remove the drive shaft, I need to replace the motor itself.
How to repair this thing.
Isn't it interesting? And by the way, before I even get there, isn't it interesting that I've got the current voltage and current.
Yeah. Sorry.
And I can verify that the unit's turned off. It's not electrified. And the humidity level is 23%, it's pretty dry, and it's pretty cool at 66 degrees Fahrenheit. So the data that I would have in my remote view is also given to me in real time, and I'm hands-free.
Yeah, and you will show later is like how this data is flowing and coming.
We're going to peel the covers open.
Yeah.
We're going to see how this is flowing through IoT Hub and into ThingWorx, and how we realized this demo.
And one thing I would say is none of this video has been edited. So everything you're seeing is actually, we brought in the motor, the full hardware setup last week. We did a pre-recording. So you're seeing a video of Surface doing AR and doing this whole experience. So none of this is movie magic. It's actually in real time.
What you see is what you get.
Yeah, exactly.
This is the augmented reality experience. And these animations that you're seeing were authored in PTC tools like PTC Creo, but could be authored in any tool that does three-dimensional graphics, which is very common for product manufacturers to produce those 3D models and animations as they're designing their product. Now with augmented reality, there's a way to leverage those same assets for the purposes of on-site training and field service. So pretty cool stuff.
Yeah, it is.
Let's peel the onion, peel the layers of the onion, and talk about how it all works.
We got what you meant.
Like Ogre has layers, right?
Yeah.
Okay, so once again, I won't spend too many time on diagram slides, but we had our remote service person who detected the problem by using the Asset Advisor application. Asset Advisor is based on the ThingWorx platform, which gave us the 360-degree view of the asset, its parts information. We're able to access the animations and CAD drawings, etc. ThingWorx also got its real-time status, the current, the voltage, the temperature, and humidity from IoT Hub. IoT Hub was receiving the edge information. What was the edge information? It was the data from the PLC and the sensor pack that's physically on the motor through PTC's Kepware product, which is an industrial protocol driver library. So Allen Bradley PLC, we know how to speak that language. The Bosch XKD sensor language, we know how to speak that as well. Modbus, MQTT, so basically what Kepware is doing, it's the Tower of Babel translator for these varieties of industrial protocols, something like 150 different protocols that we support, and normalizing that into a format that IoT Hub can do something with, a canonicalized data format through IoT Hub, processed by ThingWorx, to enable the applications. And I accidentally went to the next video, but just in time.
Yes, perfect timing.
So we have Kepware sending the data to IoT Hub, and what we see here is the VS Code, which is part of the tooling that we have.
I'm so excited to talk about VS Code, so I don't want to interrupt you. So if you haven't tried out VS Code, I highly recommend it. It's one of my favorite IDEs to work with now. What's great about it is you can have it on Windows, you can have it on Mac. I've ran it on Ubuntu. It's lightweight, it's open, it's just amazing to work with. And in the last year, the tooling team here at Microsoft has spent a lot of time making it super easy to connect to all of our services with IoT. So one of the extensions is the Azure IoT Hub toolkit extension, which I'm a huge fan of because you can create IoT hubs, you can do device management, even has IoT Edge support. So a lot of you folks working with IoT Hub or IoT Edge, definitely download it and try it out because it just makes the development a lot easier to work with IoT Edge. So I just wanted to do that call out because I love VS Code. So anytime I can do a call out.
Well, I'll give you a plug there too. So we built a connector from ThingWorx to IoT Hub. And when we were building that originally, there wasn't the extension for VS Code.
Yeah.
So I remember we were using the IoT Hub toolkit on the command line. And that was fine. You know, we're cool with command lines. We're developers. Yeah. But when this extension showed up with this magical, here's your list of devices, and we were just like, wow.
It just makes it so much faster.
This is what it's supposed to be.
Yes, exactly.
Yeah.
So I'm going to hit play on the video.
Yeah, and here what we see in this, we have, of course, when you have your IoT Hub, you connect through the connection string and you see the different menus and the different actions that you are able to do directly from VS Code. So you could copy the connection string, or in this use case, what we are doing is that we are monitoring the data that is coming from that motor that Joe showed earlier. So the motor is sending the data to IoT Hub through Kepware, and from the service side we are pulling that data and we are showing it here. So in the output we are looking at the telemetry data, the real data that the motor is sending, and of course IoT Hub, you could send the data in different formats, and you are able to see that data as we scroll here over. And one comment on the Kepware that I had also, Joe, is that we are with PTC Kepware today. We did not see the IoT Edge, but there is integration that is in the work for Kepware on the IoT Edge as well, right?
Yep. So IoT Edge is the perfect framework for hosting edge compute and managing updating the modules that would be performing some units of work. Kepware is fundamentally for running at the edge to do the protocol translation. So it's a very natural fit for us to have a formulation of Kepware that will be an IoT Edge container module.
Yeah, and the cool thing is, like in VS Code, as you are able to see the data and interact with the data, you are able to see the device, but as well as if the device was an edge device, we will be able to see here the modules, so the Kepware modules, and interact with them and do the deployment as well from central way. And so what happens in the demo that we have is like this data is consumed by ThingWorx, and that's what Joe will show us in how we get this data in ThingWorx and how we get it into the screenshot that you shared earlier, right?
You bet. Now, of course, this podcast or videocast is an IoT deep dive, so it's for the technical architects and for the developers. So we're showing you the behind-the-scenes view of what's happening so that you have an understanding of how it all fits together. It is our goal to not require you to be parsing JSON. Obviously, end users are going to use an application like PTC's Asset Advisor, which is connected to IoT Hub. But it's important for you to have an appreciation for the hard work that's gone into IoT Hub and ThingWorx, so that you, as the technical architects and developers, can build on top of that, so that you can get your customers faster to value in what they're trying to do, and not having to reinvent the wheel, like moving messages through an MQTT protocol bus and so forth.
Exactly.
That's cool stuff, but you probably don't need to be writing that code anymore.
Save a lot of time.
Yes.
So all that is taken care of.
It's all taken care of so that you guys can work on the higher level stuff, the more interesting stuff.
The coolest stuff.
Yeah.
The coolest stuff. So we're kind of marching up the stack here now.
Yeah.
We were looking at VS Code and we saw some raw messages flowing through IoT Hub. This is ThingWorx Composer, and in Composer we're building that view of the asset. So we're combining data streams from IoT Hub and from other business systems. But in this case we're configuring the IoT Hub itself. So this happens to be where we connect ThingWorx to an IoT Hub. I'm using the singular there, so you create a hub in the Azure portal, and you tell ThingWorx, this is where my hub is. And I can invoke, as the ThingWorx platform, various services of the IoT Hub itself. So we can configure device twins, we can configure container modules for IoT Edge. All of the stuff that IoT Hub exposes, it's our goal to make that connected to ThingWorx so that you can drag things around in a configuration interface and configure pre-built solutions as much as possible. So this is just a quick view of some of the services that are exposed by IoT Hub that ThingWorx has an abstraction for. I'm going to kind of zoom forward here just a little bit, something a bit more interesting. So now we're drilling into, I'm going to pause real quick. We've drilled into a thing. So this is represented in IoT Hub as a device twin. So as you're reading about, I'm sure you're going to be reading if you haven't already, background information on how Microsoft's IoT Hub works, how PTC ThingWorx works. An IoT thing in ThingWorx and in IoT Hub are connected. So you can provision them in one place and they show up in the other, and the data is shared. So this is our connection to the applications. Applications will be built on ThingWorx, and ThingWorx is integrated to IoT Hub. In this case, I'm looking at my current, humidity, operational efficiency, temperature, and voltage. So in this small example, what I care about of this thing, in this case our motor, is its sensor data, current and humidity, temperature and voltage, but also its operational efficiency, its OEE, which is a common term used in manufacturing.
And some of these values, we get them directly from the device. Some of them are calculated, right? So some of them were those that we were seeing on VS Code earlier.
That's right. There was no OEE sensor. OEE is a synthesized property. And the cool thing about it is it could have been through a business rule that a developer or a business analyst coded in ThingWorx to say when my manufacturing output looks like this and my asset reliability looks like this, compute my OEE, which is a magic number based on some proprietary algorithm that my business cares about. Or it could be a prediction for machine failure.
Yes.
And that might have been through, again, a simple rule or a fancy AI
Machine
algorithm.
learning.
The goal here is to normalize that all down to the stuff I care about when I'm looking at this asset in an application.
And again, it's in user-friendly way for an operator, right? So
that's right.
Exactly.
Yeah. Now, even speaking of personas, the user of this interface is not the business user. It's the system administrator. So you don't need to be an architect or a software developer to be using this interface. You're someone who's supporting the business applications, probably IT. Now, you might also be an architect. That's fine too. We're architects. You guys are probably architects. So understanding how all this stuff is wired together is the goal of this this short video. Okay, so the values that we're seeing here, by the way, are the real-time values that are coming from a connected motor. In the case of this video, I believe it was connected through a cellular network. So I heard. So again, the connectivity, Wi-Fi or hardline or cellular, is all abstracted by the time you get through IoT Hub. Now, that being said, as the software architects and the system architects, you do have to be mindful about choosing the right physical connectivity. We're seeing some 5G opportunities in manufacturing. Believe it or not, there's plenty of wires in a factory, but it's still sometimes helpful to use that high bandwidth cellular connection.
Yeah. And then also that's why a big reason people are interested in IoT Edge is because you can have that extended offline support too. I just wanted to throw that in there.
Yeah, so that's very important. Sometimes we get questions from people who are rather new to IoT, and they're like, hey, if my thing's not connected, can I still see anything about it? Like, yeah, it's okay. I mean, the network is not reliable, right? That's the mantra.
Exactly.
It's cool when it's live connected and you can interact with it right now, but we're expecting that that's not always the case. So the most recent status and when that status was received, and here's a good example where it's last updated, these things last communicated on this time. We last received the temperature value at this time. Those are important concepts because these things might be on a boat and they might be out of coverage.
Oil rig or anything like that,
And we provide in the Azure IoT services and on ThingWorx solutions the capability also to get alerts or to get information on how that device is working. Like, did the device connect from the past 5 days, and we enable the capability to use that telemetry data to see if you want to act on the device if it did not send any data for the past 5 days, for example, or 30
that
days,
might
whatever,
be
right?
an alert, just that it hasn't communicated in 5 days might be the problem.
Yeah, yeah. And the other aspect, I think, is the notion of real time, because we use the word like real time a lot, but like I think one thing that we need to be mindful of is that the definition of real time is different from an industry to another, from one use case to another. So sometimes it's like 1 second. Some people will say it's real time. Sometimes it needs to be nanoseconds.
Right.
So.
A real-time operating system doesn't multitask. It probably doesn't have an IP stack because it's mission critical. This would be a PLC controlling a safety solenoid on a motor that's maybe bringing a blade down. Right, that's an example of a real-time operating system. When the button's pressed, stop the blade. That's real time. 5 milliseconds.
Better be.
100 milliseconds is not real time.
Yeah,
that's a great point. And that's where the cool and the critical intersect.
Yes,
right?
exactly.
There you have it right there. There's an example of that. Okay, so let's see, where are we in our? So we actually already did this one.
Oh.
Okay, so another important aspect of IoT, we've been talking a lot about data receiving. So ingestion of data from machine sensors and so forth, so that we can trigger alerts and look at the data flow, etc. We also, not as commonly, but importantly, want to sometimes send commands to things. We might receive 1 million values a day from a connected motor, and once in a blue moon, literally, we need to send it a software update. But when it's time to send a software update, we need to be able to do it reliably. And so IoT Hub has a bidirectional communication to the asset, in this case, the edge agent that was running on our Bosch XKD. And we're able to control, through Kepware and its connection to the PLC, physical actuation of the motor. It's going to be a little hard to see in the thumbnail, so bear with me. I'll skip forward over here. This is the system administrator view, not a end user application, but we're going to execute a remote command. So we click the execute button. That
turn off.
You can see.
Yeah.
It's really hard to
really
see.
Tiny.
But trust us, if you were in front of the motor, you would have seen it. The solenoids, there are 2 solenoids attached to, maybe I'll just quickly go back to, and I'll talk through this instead of trying to look at the tiny video.
Yeah, and a big reason why we're not, we pre-recorded was because this motor is pretty loud. So we wanted to make sure that you guys weren't just hearing this loud motor running the entire time.
Which, by the way, is pretty common in industry. Places are loud.
We have to make a decision between you guys hearing us or the motor.
Yes. So this motor, go into slideshow mode. This motor had, if you recall, a PLC. What happened to my? Oops, sorry. This motor has a PLC which is connected electrically to these solenoids. The PLC is, as we talked about, a real-time OS. It doesn't have an IP stack. It doesn't know how to do cloud-based communications. So that's happening on this Wi-Fi module. We're sending a command to the Wi-Fi module and telling the software agent running on that module, talk to the PLC and ask the PLC to set its output for solenoid energized to on. All right, so that's how it works behind the scenes. Kepware knows how to talk to the PLC. The Edge module knows how to talk to IoT Hub, so it's brokering that connection between the physical asset and its actuation through the PLC and electronics and electrical servos, and in this case a solenoid, and giving it an energize command. So that's industrial IoT for you. Certainly not the beginning or the end, but maybe a slice of the world that we live in and the world that our customers have been implementing solutions in.
And I want to do a shout out to all of our folks on chat. Thank you for helping out to answer questions. They've done such a great job that I haven't had to ask any questions as the host publicly. So thank you, Carl, Stefan, and Olivier, and others on chat. It's super helpful for you guys to be there. Since we don't have any questions because they were all answered, I think we can go ahead and jump into that last slide to talk about resources.
Okay. Actually, if you don't,
go ahead.
Because we've got a few extra minutes, maybe we can talk about, Chafia and I can talk about what we see on the horizon.
Perfect.
So we've done a lot of work together and combining our technologies in support of solutions like these. So I'll start with, I'll interview you for a moment, Chafia. What do you see as the next critical cool capability that intersects with critical needs in the use cases that you've been seeing?
I think in the industry, the one cool thing that I would expect to boom in the next few years is the intersection between the IoT and the simulation. We tend to talk about it like we hear all about the digital twins, which is like the digital representation of a device or a physical piece. But in IoT, one thing, when we are a company that building new products, is sometimes we don't have all those data. Sometimes we don't get all the context about the product. And when I'm building a very expensive new product, I want to simulate that missing piece of information. So the thing is like, how do I do that? How do I bring the simulation aspect to the physical, the context data that I get, and I build a real digital twin for that device? So I think there will be a very interesting innovation around that, and I'm hearing a lot of like requests and interest from customers in that space.
Yeah, that's really, really interesting, and we have a partner, Ansys, who is working on this, and we're collaborating with them. So just for everyone to kind of get up to speed, there have been for quite a number of decades, in fact, the activity of building computational fluid dynamics based simulations of physical products during the design of the product. So I want to understand the finite element analysis and mechanical phenomenon, the physics-based phenomenon that my design will undergo with the forces and temperature and et cetera, thermal characteristics over the shells, et cetera. So there are companies that have specialized in such mathematical models. Ansys is an example. So finite element analysis, computational fluid dynamics. The thing is, it takes a while to run those calculations. And so it's good for the design activity. Here's my design, maybe here's the CAD model, I'll dial in with PTC Creo, and I'll build a computational model of the thermal characteristics and force characteristics. Run that simulation, go have lunch. I mean, it's not that slow, but it's still not real time or hasn't been real time. So here's the cool stuff that's happened. Machine learning happens to be very matrix oriented, right? So it's processing numerical matrices. We had the collective technology world had the insight not too long ago that a GPU is fantastic at matrix multiplication for calculating three-dimensional graphics. So using GPUs for AI, fantastic, right? It also turns out that the simulation stuff is also matrix mathematics. So companies like Ansys have been adapting their simulation models and calculations to take advantage of GPUs, and it's gotten so fast and near real time that we can imagine having that simulation, which was already built when the product was designed, deployed at runtime and actively looking for anomalies based on the simulation. Sometimes machine learning and AI is a good fit. Sometimes augmenting what the machine learning is doing with those pre-built simulations fills in a missing piece of data that the sensors may not capture.
Yeah. And the coolest thing is like we bring that to the edge as well. That's the work that is ongoing.
Right
like
where
the
it
market,
needs to happen.
Yeah, exactly.
Yeah.
So not like we don't need anymore all that compute power to be in the cloud or centralized ways. Like we are getting that closer, as you said, where it needs to happen.
Right.
So
good.
If we have, are we good to close or still have?
Yeah,
2
I think
minutes?
we're good
Next.
to close. I think you're totally correct on that. Digital twins and intelligent edge is just where we're going to see a lot more information and more folks doing more support there. So for resources, we have a couple links for you. One is the PTC Microsoft landing page, and I will make sure to upload these slides on our tech community. If you haven't gone and checked out our tech community site, we have one specially for IoT, so I'll make sure to upload these slides there. PTC also has a developer portal homepage. Is great for tutorials, how to get started, all of that. They're also developing, if you guys haven't played with the MX chip, they're developing a lab on how to work with ThingWorx and Azure IoT together. And so this MX chip dev kit you can get at Seed Studio, you can get it at a lot of different places, but it's nice because if you don't have a hardware engineering background, it's perfectly fine. I do, and I still really love this device. You get connected right away, connected through IoT Hub, working with ThingWorx. So the lab they're still developing, but in a couple weeks, if you go to that developer portal homepage, they'll have that lab for those folks who have this kit or wanting to get this kit to quickly get started.
Yeah, and by the way, I went through the lab myself last week with an MX chip, and even for people like us that have been doing IoT for, it's pretty cool. I mean, it helps you, especially if you're new to IoT. It helps you understand the concepts. What is the role for the edge agent? How does IoT Hub really work? The stuff that we've clicked through, the screens and videos we showed today, you can get hands-on with that stuff and get an appreciation for it and understand where, as you're implementing projects for customers or your own companies, where your value should be and how you should interact with these tools.
Exactly, and what's nice, it also has a lot of sensors already on there, so you don't have to worry about breadboarding a bunch of sensors to the device just so you can...
No jumper wires.
No wire wrapping, none of that to work with the device. You can really get started on the cloud side. And then we have an upcoming event, so Hannover Messe, if you haven't been to that event, it's one of the largest events for Industry 4.0. Everyone's there who's part of that industrial industry. So I highly recommend checking out PTC there. Microsoft will be there as well. Chat with us, and we would love to meet up with you guys.
Yep. I will be myself there, so feel free to reach out. We'll be happy to meet in person.
All right, great.
All right, well, thank you so much for joining on our first IoT Deep Dive. We're going to be doing these on Wednesday, every other Wednesday. So definitely, if you have ideas for future deep dives, anything that you really want training on, let me know. Thank you, guys.
Thank
All right,
you.
thank you.
Thanks.
Thank you, Pamela.
Bye.
Bye-bye.